Okay, so first let's look at example 1. We did this yesterday in class. So in the example, you're here on this side of the river and you want to go you want to go to the campsite on the other side. So you head your canoe across and you're going 4 meters per second east in your canoe. The problem is the river has a current and it's flowing south. So the river's current is 2 meters per second south. And what that means is you're not going to end up at the campsite. You're going to end up down here. And we can find this by just doing Pythagorean theorem. So this is my resultant. This is the speed of velocity of what I'm doing with respect to the land on the side. So the 4 meters per second is what I'm doing with respect to the water. The 2 meters per second is what the water's doing to me. And so the resultant of adding these two things together gives me the red diagonal vector here, which is what I do with respect to the ground. We can find it by squaring the 4, squaring the 2, adding them together, and getting 4.47 meters per second. But it's a vector, so we have to find this angle, theta. And so you can find it by doing tan theta. So tan theta of 2 meters per second over 4 meters per second. And we did this the other day. So when you do inverse tan of 0.5, you get 26.565. So 26.565 degrees. So we would go square bracket, measuring from the east, 26.565 degrees, and it's going south. Okay, so that's the answer to part A. And then it says the river is 800 meters wide, and it wants to know how long is it going to take you to go across. Well, if it's 800 meters wide, that's your delta D, and this is the speed with which you're going across, regardless of what the river's doing. So from this, we can use our VAV is equal to delta D over delta T equation and find, rearranging, delta D over VAV. So 800 meters over our 4 meters per second. And we find that it's going to take us 200 seconds to cross the river. Now, we did this the other day right at the end of class. And what I said was, as you cross the river, it takes 200 seconds. That 200 seconds is the same amount of time the river has to push you downstream. So you're going to end up downstream a distance, delta D is equal to VAV delta T. You're going to end up downstream 2 meters per second times the 200 seconds. You're going to end up downstream 400 meters. Okay, that's part C of example 1. This was part B, and this guy is part A. Now the thing is, though, you don't want to end up down here. You wanted to be at the campsite, so you now have to pick up all your gear and walk up the side of the bank to get to your campsite. But if you were a true physics student, you would be like, no, I'm not going to do that. I'm going to use my brain instead of my muscle. For some of us, we don't have enough muscle, so we better use our brain. I'm speaking about myself. So you start here and you want to go across here. You want to end up. You want this to be your resultant, not some crazy line at an angle that ends you up downstream. So you use your brain and you say, well, if I know the river is flowing south, and if I aim straight across, I'm going to end up down here, then I'm going to be smarter than this river, and I'm going to paddle into it. I'm going to aim north, like east but north of the river, and I'm going to let the river bring me down. So this is still what I'm doing with respect to the river, 4 meters per second. It's just not east anymore. And it's not pure east. And this is what the river's still doing, still 2 meters per second south. My resultant now, though, is a different value. So the question in example 2 is, what angle should you hit to make this happen? Well, it's a right angle triangle, and I have the opposite, and I have the hypotenuse. So in part A, I just have to do sine theta, opposite hypotenuse, and that's 2 meters per second over 4 seconds, meters per second, 0.5, so theta's 30 degrees. 30 degrees from what? Well, I measured it from the east, and then I turned and headed north because the river's flowing south, so I have to head north. So part A's answer is east. You should head east 30 degrees north, and that way the river will bring you down. Part B wants to know, well, what speed then? No, actually, I don't have the question in front of me, but I think maybe it asked for time. So our river is still 800 meters. So if I want to know how long it's going to take me to cross this time, I still need this velocity. And I can still find it with Pythagorean theorem, only this time it's not the hypotenuse, it's one of the sides. So it'll be v squared is equal to 4 meters per second squared minus 2 meters per second squared, because you're finding one of the legs. So 16 minus 4 is 12. Take the square root of 12 and get 3.464 meters per second. And maybe it does ask for this, because I think it says what's the magnitude. Okay, and it's going to be east. Magnitude just means what's the size. So you don't actually need the direction, because we already know it's east. So there must be a part C that then says how long will this take you. So we now have the speed of this side. We know it's 800. So we go back again to VAV, delta D over delta T. We rearrange for delta T, and it's going to be delta D over VAV. So this time it's 800 meters, and it's over the velocity going this way, which is the 3.464 meters per second. And so this time, our time is 230.94 seconds. 230.94 seconds, which is bigger than how long it took us over here. It only took us 200 seconds when we went straight across, but we didn't end up where we wanted to be. We ended up downstream. It should make sense that it's going to take us longer this time, because we're heading into the river, into the current. We're actually going further, right? We're going the hypotenuse. But we end up then, in the end, at our campsite where we want to be. Okay, so that was example 2. So now on page 110, I think you had 4 or 5 questions. The first one, number 21, is you in the river, and you are going 3.5, I think it is. Yeah, you were traveling 3.5 meters per second upstream. So you're going into the current. Somebody standing on the shore sees you only traveling 1.7 meters per second upstream. This is your resultant. So what must the river be doing? Well, the river must be working against you, right? If your resultant is 1.7, but you know you're going 3.5, the river must be going against you downstream 1.8 meters per second, the difference between them. And that's it. That's all you had to do for 21. For 22, it says there's a jet ski dude, and he goes 100, is it 100 kilometers? Oh no, I'm on the wrong question. That's number 24. Hold that thought. I'll come back to that in a second. And number 22, I should look at the textbook. You're on a river, and you're heading south. So you're on this side of the river, and you want to go south 11 meters per second, and you're going south. But the river is flowing west 5 meters per second. So the river is going this way 5 meters per second west, and it wants to know what's your resultant. It just wants you to find this vector. Okay, so you're going to square them, add them together, take the square root, and the red line again is what someone standing on the shore would see you doing, because it's what the river is doing to you and what you're doing to the river. So